Uh, Hello, everybody. Today's lecture will be about C and Matlab, the connection between C and Matlab. Now, thus far we have used Matlab in its own environment. We've used a Simulink, and what if we have a particular C code? And for example, also a library, but I'm not going to touch that because that would be too much detail, but it will be possible to integrate also a library into Matlab. Now, what if we have a piece of code that is written in C and we want to integrate this into Matlab? For certain cases, this becomes very handy. For example, I myself have tried this on using OpenCL with Matlab, which is basically a parallel computing toolbox. You might want to check it out. It's actually very cool. What it does is it uses your graphics card, your CPU in a parallel programming setting. Now, it is possible to integrate such libraries into Matlab, and the advantage would be then coding in C with low-level capabilities, which has high performance in terms of computing power or reduces the computation time. So in such advanced use cases, it is possible to have the need to integrate C into Matlab. Now, there are two possibilities for C integration into Matlab. One of them being to import the C library directly into Matlab environment. That would be via using this Matlab compiler, Matlab executable compiler, which is MEX. And therefore, it is possible to code your C code or function and then port it into Matlab and use the compiler MEX, which will generate you a Matlab compatible file that will then be loaded into memory, and then you can call that function within Matlab, which is, in my opinion, very neat. And then there's a second possibility, which is even more advanced. The second possibility is to integrate your C library into Simulink. Now, this part is even better because most of the time Matlab users, especially the control engineers, like to use the Simulink graphical user interface, where you drag and drop some function blocks, connect them, and then you have your system in Simulink. Using less code and having the ability to drag and drop and connect blocks together is also very handy. That's also possible, but you have to take more care and a little bit more help from Matlab or Simulink. We will also see a basic example on how to embed C functions or C code into Simulink. Now, let's start with a very basic example. For A, let's write a function that's basically taking two operands and sums them together and returns that value in C. Now, of course, this doesn't make that much sense here, but this will be just to demonstrate how this works. Now, therefore, we have to create a, let's say, main.c file. And let's have, maybe I should increase the size here a little bit. So hope that this is sufficient. Now, let's have include and, for example, stdio.h. Now, let's have a main function here, return 0. So what we try to do here is we assume that we have a function. Let's call it float, and let's call it sum. So let's have two operands, float A and float B, and let's return A plus B. So very basic, nothing to worry about. And let's also have to float variables defined here. Let's say float b equals 2.2f. And then use printf, for example, to say .f plus %f equals %f. We need a, we need b, and then we will use the sum a comma b here. So let's also have a new line. So this is basically it. Now, if you have a C code, you have to install a compiler, which I'm not going to going into detail here. Let's assume that we have the compiler. I have. Let me quickly, or maybe I should use this one here. It's also possible. Now, usually you will use an IDE, but I'm kind of old school, so I like to use the command prompt here. So we have this .c file, and usually the way we compile this, in my case, I have MingV installed, which has a compiler GCC, for example, or G++. Depends on the language you're using. If you use C, then you'll probably use GCC, and if you use C++, you will use G++ here. Let's use GCC. Now we have to provide it the C files that we want to compile. Even though I have just one file, main.c, I can just pass in *.c, which means that take all the C files and compile them. So if I do this, you will see that a.exe is generated. And if I call this, you'll see that 1 plus 2.2 is equal to 3.2. So I have a library, which I assume is ready and already coded. Now, in this case, this is, of course, not that complex, but still good for us. Now, as in normal C, you will need the compiler. Now, in Matlab, you will also need a compiler here. Let me open a Matlab here quickly. So we'll have a Matlab terminal here. Now, in Matlab, you have to go through these steps for the installation. As far as I know, Matlab uses its own compilers, even though if you have, for example, Visual Studio, it'll somehow integrate it. I don't know. So there is this function called max in Matlab. So here I'm in the command prompt, and what I do is I use GCC or I use G++, which is the name of my compiler or the executable file. So in the Matlab case, we have the same notation. We again use max, which stands for GCC in Matlab, for example. And then we provided the files. Just compile everything in this case. Now, in order to have a working compiler, we have to check if it's installed or not. So there's the setup here. Now, this will guide you through the installation part. Let me just maximize this. You can see that I have a MingV64 compiler, C compiler installed, which is not my own MingV version. It is the Matlab version. And I have also Visual C++ 19. It'll automatically detect this. If not, you have to just work with it. Let me just show you the documentation of Max. So the first step is basically to install a Matlab compatible, Matlab recognized compiler. That's the most important part for this to work. Now you can see that this is basically a compiler, and here somewhere should be, there's lots of documentation that you can check out. Now, where is it? There should be somewhere a little setup here, which I, for some reason, don't see. Let's see. Choose a C++ compiler. There it is. Now, if you run max-setup cpp or C, it'll ask you to install a compiler. So for that to work, there was a page. Change the full compiler. Is there something here? Yeah, this was what I was. Oh. So let's try Google here. Matlab Compiler Max. So there should be a page. Supported compilers, I guess. There we go. In the Matlab documentation, you can see that you can download MingMe now that will be compatible. Now, there are some limitations and there are some toolboxes you might want to check out. But for the most part, it works. If you download, for example, this file here, it will install it through Matlab. This is not the usual installation. And if you have Visual Studio installed and then you run Max setup, as far as I remember, it'll try to find your installation or your compiler. So yeah, there's an extra step that you should go through. And most of the time, MingMe 64 works here. So you can just directly download it from MathWorks site. It will install it and then you will be good to go. Now, let's skip this compiler part. Once you've done that, what you can do is you can just call max and then .c. Maybe max main.c. It actually works, but I'm not sure. Max function. Oh yeah, okay, yeah, of course. Now, let us actually split this into a header file. Let's say sum.h and sum.c. So now here we can use the preprocessor if not def and then, for example, sum_h. If that's not defined, just define it. So in order to solve the solve the problem where multiple includes cause problems. So what we can do is we can just take this into the C file here, include, let's say, sum.h. This is basically usual C++ stuff. Let's take this, let's get it here. Let's have an abstract or a prototype definition. So we have this basically. And here, instead of doing this, let's include sum.h. Now, the reason why I split it into files is the following. Most of the times, when you develop a bridge, so when you integrate your C library or even C++ library into Matlab, it is a good idea to split the files, compile it in C as usual, for example, and check if it's working, and to prepare another file that will be included in Matlab and compile it to Matlab. So there might be differences or there might be problems or issues that you might want to solve. So it's a good idea to split things up. So there we go. Now let's check it. Let's check if it's compiling. gcc.c. There we go. By the way, most of the time, let me just introduce another thing, build.bat. You can use a make system or CMake, etc. But to have simplicity, I'll skip that. Now I want to compile sum.c and main.c. So you can also say echo off for Windows users, so it'll not copy and paste the code here, this part here. So you can also, as far as I know, use this -o for output name and give it a name. So if I call build, for example, There we go. It generated main.exe, so we can get rid of this. So I have a part where I have the C project sort of that uses my sum library and compiles it, and it works. So I can see that running main gives me the result that I expect. So that's good. Now, once I switch to Matlab and try to use max this here, we have a problem. Now, the problem is indicating that the max function symbol is not defined. So remember that the C compiler or C++ compiler usually looks for a special function, an entry point. In this case, this is the main function here. So what it does is it looks for this main function and go through each line and looks for all the necessary extra files and functions and classes, whatever, and compiles you the machine code, and you're good to go. Now, in our case, we don't have a program or executable, but we are trying to load a library. So, and in order to be able to communicate with Matlab, what Matlab needs here, or what max needs here, is the so-called max function, which stands for the main function of Matlab. So this is a special function that we should implement to be able to compile this and use it in Matlab. So therefore, I also created a batch file that compiles it only for C, and I don't use this *.c approach because I will be adding a file that should not be compiled with GCC or G++. So I'm separating stuff here. We have one part that only belongs to this main.c belongs to the C project. Sum.c, sum.h is shared between the C project and Matlab project, and I'm going to add a new file that will be the Matlab project, sort of. So we need a max function. And I don't have to name it this. I might just say some wrapper. It's a wrapper function. So I should wrap it in another function. So what we need here is we need to, first of all, include the max file, the max header. So there are some special definitions for max, max.h. So as far as I remember, it should be in quotes. Now, and then there's also something called matrix.h, which is optional, matrix.h. So these come from the documentation. If you just say help max and then see something like that, it will show you the basic code that I'm going to show you here. So now the basic function that we should implement, which stands for int main in our case, is the max function. So I'm just using this definition here. So we should implement a void function that accepts some special parameters. So this is sort of the int main of max. There we go. Now, when we use usual C, we have int arg C and then char pointer arg V, something like this. So this definition can be omitted by just leaving this out, or in putting in void if you want to prevent input. So the reason why we should stick with this for most of the time is the following. If you use it through the command line, you might want to pass in some arguments to your main.exe or your basically executable. So this counts the number of arguments, and then this has the character representation of the arguments. So these are strings basically, and then you have to check if argc is equal to 1. If it's 1, it is only itself, so it's only main.exe. If it's, for example, 2, then you have main.exe in quotes. So something like this here. This would be the first argument, and then you might pass in some extra arguments. For example, 2 to 3, I don't know. Then you look for argc and look what the count here is. This is the argument count. And then this is the argument vector. So this is important because we have kind of the same notation here in the max function. So we will we will have parameters that will indicate how many inputs and also how many outputs there are and what their pointers are. So yeah, we need the number of left-hand side arguments, NLHS. And then we will also have mx array, which is again a special structure of the max function, pointer of left-hand side. And then this is also a vector. So this is the left-hand side. So for example, if I call, let's say y comma t equals step, and then I use something like this. So this is the MATLAB code that I use most of the time. You can see that we have two output arguments. So in this case, int NLHS should be equal to 2. So this is basically 2. And then the mx array here stands for the pointers. So we have the pointers here. So if I use PLHS 0, for example, this should be, let's use arrows here. This should be the pointer of y. So basically, this is the pointer of y. I don't want to confuse you with the syntax here, but this is basically what it is. So it is a, for example, something pointer, so some type pointer here. Therefore, if I use this, if I want to access its value, I should dereference it by using star y. And we will come to that later. So, but basically, this is the important part. If I have 1, this should be equal to 2. So this structure here helps us in emulating the MATLAB syntax. Since we are in C, we don't have that capability. We can't just use something equals and then the max function. That's not possible. But if someone calls our function, then this wrapper function ensures that it has the corresponding outputs, the corresponding inputs. It takes care of everything, basically. So we also need the right-hand side, because this will be the actual input argument. So in sum, for example, in sum.h or c, I have 2 arguments. This is the right-hand side. So basically, we also need our NRHS and PRHS. So let's copy this and paste it. Once you get used to it, it'll become just, it will be very natural to you. So number of right-hand side arguments, and then pointer of right-hand side arguments. This is the same kind of method that was already used in C. So yeah, this mx array is basically the MATLAB basic type here. And we have PRHS. Now, you could leave this like, leave this argument list like this, but in good programming practices, if you have something, let's say the mx array PRHS here, if you have something like that, you might accidentally write into it. But we don't want to manipulate this. Even if we have to manipulate this input right-hand side, we will copy it to the left-hand side. So what I mean by that is the following. Let's say we have a sum function that uses 1 and 2 and returns 3. So let's say result equals this. Let's think of this as a MATLAB syntax. Now, if I'm calling my sum library or function from MATLAB, I don't want to change 1 and 2 as values. I want to manipulate only the result here. I will read the values here, use them, have some calculations, and return something. But it is not a good idea to change what's already coming here because I don't have the permission. Okay, now if we have something like this, for example, if you use just x and 2 and it will return you the sum of 2 and x, and then somehow the sum function messes up with x, and you read the value and the value is not equal to 1, or it's even destroyed, then you're in trouble. So a function that is called from another place should not manipulate its inputs. Therefore, it's a good idea to put in a const here so that you're indicating that I'm using the pointers only to read, and I'm not going to manipulate this. If you don't follow this, if you don't put in const, it might work. It's not that big of a deal. But the problem is, semantically, you shouldn't do that. You shouldn't leave out const because you should not manipulate this variable. If you do, there could be bad allocation of memory, unexpected behavior, basically. So const should be here in place. So therefore, we have to create such a function. And even though, as far as I remember, I didn't do anything, I should be able to compile this. So let's try this. Let's say sum_wrapper.c. And there we go. We compile it. Even though it is empty, it was a void function, so I don't have to put in return something. So I did basically create a executable, Matlab executable. Now you can see that there is maxw64 here. This is kind of the exe that we generated here. Corresponds to that. With the difference, where the difference is the following: you don't use it in Windows or in your operating system. Matlab will use it. So Matlab knows how to load this executable, and it'll load it into memory, and then you will be able to use that. So you can think of this as a DLL file or a lib file, a static lib file. This is practically a DLL. So we're creating Matlab compatible DLLs, sort of, and use it there. So, because this will be used in compile time. So yeah. Now, how can we use this wrapper function? Because this has nothing to do with our sum function. We didn't use it. We didn't even include it. So let's first of all do that. Let's include our sum.h. So let's also create a Matlab equivalent of build.bat. So let me create a file, call it build.m. And what this should do is this should just use max, and then let's say sum.c and sum wrapper.c. So if we use builds, let's try it out. Yeah. Now sum has the same name and Matlab builds in. Yeah. Maybe we should rename it. Maybe Matlab is right in order to get rid of confusion here. So let me quickly do that. Let's prefix it with C. So, and in main.c we will use this here. And when we call it, it should be csum. Let's call it csum. Include csum. So let's see, did we mess it up? So build sum.c, no file. Yeah, we have to put in a C in here. So build, there we go, we've compiled it. Main still works. Now in the Matlab part, we should, okay, we're done with that. We should include c.sum, and we should be good to go. Let's switch to Matlab. Build. Yeah, in build.m, we should prefix it with this here. So build. Yeah, let's delete this. Let's delete this one here. Let's also delete this one. Let's build again. So no warning, and our generated library file or max file is called csum. Now there is a function called sum, which already takes care of the work that we try to implement, which is trivial, but for the sake of simplicity and demonstration, it is important to have a trivial example to work on. So Now, you can see the analogy here. I'm using build.bat, which corresponds to build in MATLAB. I have a compiler called Max in MATLAB, which corresponds to GCC or some other compiler. And I have kind of the same notation, which is also interesting. I feed it the files that I want to compile. And then I have an output name, which is not the case in this case, because it uses the original what does it actually use? In some wrapper, it's somehow determined that this should be CSUM, but I'm not sure how it does work. But yeah, it compiles to CSUM. Maybe the function that I'm going to call is CSUM, so therefore it might be that. So yeah, how do we implement this part? Because this is the crucial part. We will implement this, compile this, and it should work with MATLAB. So let me, by the way, just write in what is what. So NLHS is the number of left-hand side arguments, args, and then PLHS is the pointer to. So, and then we have RHS, number of right. There we go. So, first of all, what we can do is we can do the following. We can call our function now, which does nothing, by the way, but yeah. We can call it as we wish, and there's no error here. There's no problem, seems like. So first of all, we need 2 arguments. Therefore, the number of right-hand side arguments should be at least 2, because I should have 2 inputs. So in C, let's check if this is, for example, equal to 2. And then let's have else. There we go. Now, if we have, for example, 2 arguments, let's try to print f and then say 2 arguments provided. And a new line character. So otherwise, please provide 2 arguments. There we go. Now, each time I'm using it, I need to compile it because I did make some changes. So let's compile it with build. Seems like no problem. So let's call it CSUM. Please provide 2 arguments. You can see that my wrapper function works. Even though I didn't call my original function, I can check if there are 2 arguments. Let's try it again. Let's see, we have 2 arguments. It's pretty nice that I can use printf within MATLAB. So yeah, now we have checked if we have 2 arguments. So can we somehow throw an error here, for example? Now there is something called max error message text, which is a built-in function, which you can look up. And let's say, please provide, I shouldn't have deleted it, but yeah, please provide 2 args and then a new line. So let's build it again. Let's see, let's have CSUM. Now you can see that it works like any other error message. Now, printf is just for information, but here we have kind of an error sound in MATLAB. I don't know if you have heard it, but yeah. So I can define A. If I call CSUM with just 1 argument, I get the error message. Now, if I provide 2 arguments, I'm good to go. So now we have kind of checked if we have to input arguments. What we should do is we should, for example, acquire the data that is provided. So we should take the Matlab arguments here, 1 and 2, for example, and then convert it into C-compatible data, and then pass it through the sum function, the low-level function csum, and get the result and return to Matlab, so Matlab can return me Matlab-compatible results. So this is basically the steps that we should follow. Now, by the way, for simplicity, we might also use double here instead of float to have a wider range of precision. And since in Matlab we are always using double, we should maybe use double. So let's call this csum and csum. There we go. So in main.c, maybe we should use this. We don't need f now. That can be like that. So build main, and that's it. So let's come here, and we didn't even touch it. So yeah. So by the way, there's something called clearmax, which clears the loaded max files. Sometimes you have to do that because the static memory doesn't flush or something like that. There's something important about it. So if you use clear for usual variables, so you should maybe use clearmax if you run into trouble. Or sometimes you have to reset Matlab. So close it and open it again and try it again. Sometimes you get stuck with this max here because you're messing with the low-level stuff. So now I know that I have 2 arguments in this case, but I need to check if I have, for example, scalar data. Because in Matlab, you can pass in everything into a function, almost everything, and it will work. But here specifically, we have to have some type constraints for our input. So we should check if we have, for example, a vector or a scalar. First of all, we can start with that. There might be ways to implement this sort of bridge function or max function so that it will determine its size and the corresponding low-level C function that should be called, and calls that and returns the value. So we will see if it's possible or not. So we need to get the size data because I can use csum here and then provide it a vector like this, for example, and it'll say that there are only 2 arguments. Now, is this a vector? Is this a scalar? I need to determine that. Now, if you use Matlab enough, you might be familiar with this here. So size, and then maybe let's have 1, 2, 3 here. And there we go. Now this M and N is widely used in Matlab for rows and calls and the number of them. So the same notation follows here. We will have some special max functions that will help us out here. So there are max-specific functions that need to be used. For example, one of them, and most of the time mx stands for max. So if you have prefix mx, you can pretty much be sure that this is a max function. So yeah. So I want to get this M and N into C. And as the name implies, I can get M here. So in order to call get M on a specific operand here, for example, the first argument or the second one, I need to provide it the pointer of the data. So I know that there are 2 right-hand side values, and I have therefore 2 pointers in here. One of them should be in 0, and the other one should be in 1, stored in 1. So these are only pointers, by the way. And getM uses pointers. Therefore, what I can do is I can get this here. So this will determine the number of rows for the first argument. It might seem a little bit odd, but you will get used to it. So if I have, for example, the number of rows here, what I can do is I can just define something like int and then M1, for example. So this should basically work. So let's try this out. Let's say the first argument has %d rows, and then provided M1. So let's build it. So we did build it. Let's call csum with a vector 1, 2, 3, maybe, and then maybe 1 and 2. And I guess we crashed. So yeah, it doesn't work anymore. So you have to restart. This was a perfect demonstration of what could happen. So yeah. Now, left-hand side, that's maybe the reason here. I should have used the right-hand side. You can see that there's no allocated PLHS0, so I have no output. Therefore, if I check that and if it's null, I get an exception thrown, which I even didn't see here. So let's try to exit, but yeah, it kind of terminated. Good. Now, open up in the Matlab terminal. There we go. Now let's build. Now, most of the time, if your compiler doesn't complain, and if you run your executable or whatever and run into problems, you should be the one that should see what the issue is or what the cause might be, because the compiler doesn't help you out. So those types of errors are the most dangerous one, because there are no syntax error, there are semantic errors. So yeah, csum, let's try this again. Hope that this time we will not crash. There we go. Nice. So you can see that the first argument has one row, or rows in this case. Yeah, it has one row, which means that this is a row vector. So what happens if I change it to a column vector? You can see now I can determine that there are 2 rows. Now this becomes quite handy because Matlab has a specific implementation for its matrices, its arrays, sort of, and you can use getM to determine how many rows there are. So following the same notation, we can determine how many columns there are. GetN. So it should get M and N. So maybe the size of the first argument, size of arg1 is, let's say, %d, and no rows anymore. So M1, comma N1. Let's build this. Let's clear maximum. Build. Nice. Now let's run csum. There we go. Now you can see that the size of this is 2 by 3. So if I would have called size here and M comma N, that would give me 2 by 3. So you can see that we have basically the same data here using mx get m and mx get n. So I can do this for the first argument by using 0. And I can do the same for the second argument to check if it's what the size of it is. So let's do that. The only thing that I should change is the index here, because I have 2 arguments and we are in C. The indices start with 0 and the second argument will correspond to 1. Let's have size of arg2, use m2 by n2. So let's build this. Let's run it again. And maybe I should use the arrow key here. So there we go. Now we can determine what the size of my first argument is and what the size of the second argument is. By using doc mx get m, I guess it should help us out with the documentation. So let's see. So you can see that there's also a Fortran or C++ bridge here, but yeah, get m. You can see that you should include matrix.h, which we did already. This comes from the documentation. Mx get m uses a const matrix PM and determines us the size here. So we have get n also, which I've already used. And I was looking for something else. Is there another dimension? What if we have a 3D vector? I didn't try that one out, but get number of dimensions maybe helps us out here. Maybe it will show us how many dimensions there are. But that's also it. Now, one of the hard stuff about this max porting is that the documentation sometimes lacks a little bit of examples, and you might get stuck very easily. So having a good starting point with the basic knowledge is essential here in this case. So therefore we have this video, hopefully. Now I can determine the sizes. Get m and get n is sufficient for now. Now, since my function only uses scalars, I should maybe restrict it to scalars. So therefore, let's have an if statement. So let's have again if, and let's say m1 should be equal to 1, and m2 should be equal to 1, or n1 should be equal to 1. And also m2 and m2 should be equal to 1. So if this is happening, then we're good to go. If not, then we will use this error here. You can implement your own error system here by using macros and functions and stuff, but yeah, not really. I don't think that's the main point of this lecture here. So what is the error? Well, only scalar arguments are supported. Yeah. Now, otherwise, now at this point, if I have determined that there are two inputs, if I have determined that both are scalar values, the only thing that's remaining here is that we should have the pointer, the data that is stored in it. So let's get the data. So in order to get the value out of the Matlab file here, what we should do is we should use, again, PRHS0, for example, for the first argument. Now we need the C-type pointer here. So therefore, we will define a double pointer. And this pointer would be, let's say, pointer here. So we should say the pointer should equal this. Now, you can see that we have a double pointer here that will hopefully give us the numeric value, so the double value of our argument. But you can also see that PRHS is an MX array. So this line 25 is not really possible in this case because we have a const mx array pointer, not a double pointer. So we need to call a function, a helper function that will get us the double pointer here. And as in the case for mxgetm, it is possible to get a low-level pointer, mxgetpr. So this function here will return us, hopefully, the double pointer that we then use to access its value. So we use mxgetm and n for the determination of sizes. We use nRHS to determine how many inputs are provided to this function in MATLAB. And here we use mxgetpr to get the memory address compatible to double pointers. So we are looking to get a double value out of it. So this is basically casting this const mx array into a double pointer. So now once we have the pointer, what we can do is we can pre-allocate A and B, fields A and B. Did we use A and B? I guess not. So we can define our variables double A and B. And then what we can do is we can do the following. A should be equal to what PTR points. So the value stored in that pointer should be A. So before we go on, before we continue, let's look for the value. So let's say arc1 and then F and then A. So hopefully this should show us what the input is. Let's build, no problem here. And then let's have C sum and 4,4. Now we can see that here we have double A, and this A is determined by the value of the first argument that is a MATLAB type. So if you use the workspace in MATLAB, you will see that there will be a double 1-by-1 value or variable named A, or yeah, if you use, for example, A equals 4 like this, it will define a variable named A that seems to have the data type double 1-by-1. But that double type is a MATLAB type, not C type. Now here we have used the first argument, the value of the first argument. Since we have the pointer to it, we've used the pointer, converted into a double pointer, and then we extracted its value to A, which is a C variable. This is, in my opinion, very nice, very neat here, because I can have the C equivalent, store that, call my C function, return it, and then convert it back into MATLAB. So this is a direct embedding method here. So if I can get the pointer of the first one, I also can get the second one. So now I have copied and pasted it. The only thing that will change is the indices, so the index here. And I will get the next pointer, which is an MX array pointer, by the way. I get the next one, this one actually. And again, I have to say B should be the value, whatever is stored in this pointer. So now we have A and B. So let's see what A and B are. There we go. And then let's have 4x4 or 5. So what happens if I put in a vector accidentally? You can see only scalar arguments are supported. And I can see there are 2 arguments. Of course, I can get rid of this to be professional. Now, this csum max file has a type checking mechanism that'll help me out in determining whatever the arguments are, if they are properly sized, and so on. Now this is basically 50% of what we try to accomplish here. So what should we do now? Now we have double A and B. So it is basically safe to create a result, a double value result. At this point, I seem to be safe here. So let's say result is equal to my function csum A, comma B. And then maybe printf the value before I return it to Matlab. So result, and then %f, and then a new line character, and result. There we go. So build, nice, 3,4, 7. Now, of course, this is not an interesting example. Seeing 3 plus 4 is equal to 7 is not really that important, but you can see the potential. You can see that I might have a library that will be called there, and then I might get, for example, it might be a computer vision algorithm in OpenCV, for example. You might have a code there. You might want to integrate it for some reason into Matlab, even though there's already, computer vision algorithms in Matlab. Maybe this one is different, I don't know, or has a higher performance. So it is possible to get the, for example, image data from Matlab, pass it through this max function wrapper, and then pass it through your algorithm, get back and pass it back to Matlab. So this is quite nice. What else? So at this point, I'm determining the value, but I'm not returning it. So how should I do that? Let's see. Well, if you try to do something like this, which makes kind of sense, but is not really the way of doing stuff. So let's say we again use this here. Since this is our pointer acquiring and casting mechanism or function. So this function takes the appropriate operand pointer that is a Matlab type, converts it into our C type pointer. So therefore I will use it on and on. So if I have the pointer for left-hand side, because this will be the output, so that will correspond to this one here, PLHS, and the first one, of course. So is it possible to use this pointer and then try something like this? The pointer should, the value that is stored in the pointer should be equal to the result that I've already calculated. Now, if you are a C programmer or C++ programmer, then you might see an issue here, or you should see an issue here. The reason is that we didn't allocate actually this pointer here, PLHS. So this might be null here, a null pointer, because we didn't allocated it. We didn't call malloc, for example, on it. Of course, another thing is that we shouldn't really call malloc from C, because this will then be converted into a Matlab compatible data type. So this is not really our duty here, but we should maybe inform the max mechanism here that an allocation should be happening here. So maybe we should ask max to allocate it for us. So therefore, before I get the pointer and then put in my data into the address that is given, I should allocate it. So PLHS 0 equals. Now, if there's a function, again, helper function that is called create numeric matrix, because we are in Matlab, which is matrix laboratory, I guess. And here, I want to create a scalar. So the m and n values should be 1, 1. And I should also provide it a type, because in malloc, the way that we use malloc, if you don't remember, let me remind you quickly, is that we give it a size. So yeah, if we say, for example, 4, what malloc does is it allocates 4 bytes of data or memory, basically. So if we want to, if I pass in 1, then this will basically allocate 1 byte data, which corresponds to a character in C in memory. But for integer pointer allocations, we most of the time do something like size of and then the size of int, for example. So what this determines us, if you're on a 32-bit machine, this will give us 4 bytes. So therefore we allocate basically 4 because that's the size that is required to store a int value. So therefore we need to be aware of the type of the allocation that we do, and MX create numeric matrix needs also the type here. So we give it a double, but not the double in C, but the double class that is basically a class indicating that Matlab has more to it in its type. So this is not just a double data type, this is a double class, sort of an implementation for Matlab. So, and then we need the last argument, MX real, which indicates that there are 2 different double type data in Matlab. One of them is the real one. So if you use 2, this is a real double, but you can also use 2 plus 2 times I, which is indicated as complex, but which is basically a 2D double data. So if I say MX real, then this will be a real valued double. If I use MX complex, something like that, complex, I guess, that should be into documentation, then this will be corresponding to this one here. So yeah, MX real is more than enough for us. So this way, hopefully, we should be allocating left-hand side argument 1. And then we can get the pointer and put in our value. So hopefully, if I compile this, yeah, it didn't compile. So I guess MX real should be all in capital. That's my first guess. Let's see. Yeah. Now, it seems like we are good to go. Let's try this out. Let's provide it a 2, a 3, 4, and hit enter. And now we have 7, but in the Matlab sense, because if you don't provide it a variable, if this is not, for example, result equals csum, then ANS, which is the default data or variable name for Matlab, is automatically generated. If you provide it res equals csum, then you get this. Now it seems like for some reason someone could, and I hope that this does not crash, someone could try to do something like this, but it seems like, yeah, is it still working? Yeah, it's still working. It's not that fatal, but we should also handle the multi-output possibility here and indicate that this is not really possible because our csum is just using the input operands as scalars and returns a scalar sum. So it is quite easy to do this. It is possible to say this should be equal to 2. And let's say number of right hand side is this, left hand side should be equal, maybe we should switch order here. So let's do this quickly because this is on the left, this is on the right. Yeah, this should be equal to 1, but I'm not sure. Let's try this out. Yeah, so this should be equal to 1. Otherwise, please provide 2 input arcs and 1 output arc, sort of. So let's compile it. Good. So let's say csum 3, 4. Yeah. We didn't provide any arguments, so that might be the reason. Let's try to call it like this. Yeah. Now, this is a bit odd because maybe I don't want to define any variable, but I want to use A and S. Now, we have somehow eliminated this possibility because at the time when we're calling it, I guess we didn't create the output here, so it couldn't assign it. So some weird behavior, basically. What we could do is we might try something else out here. Maybe we should say that it should be less than or equal to 1, which might be a better idea. So if it's 1, I'm okay. If it's 0, that should be the case where A and S is defined. So maybe that makes sense. So C sum 3,4 works. If I have result equals 3,4 also works. If I try to have multiple outputs, let's say Y, res, and then this here. Oh, I guess we crushed, or oh, we didn't hit enter somehow. It throws my error. Please provide 2 input arguments and 1 output argument. So basically, we seem to be safe in the sense that we have we have checked if we have enough arguments, exactly the count that we need, and we have checked if we have inputs and outputs that are compatible. Seems to be pretty much it for this function here. So now, as far as I remember, let me show you something. Let's create a temporary folder. Let's copy this here into the folder, and let's basically, yeah, let's change directory into temp, clear CLC. Now, if we hit csum, you can see that I can use it. Now, where am I? I'm in this directory temp here. So you can develop your max file in a certain folder, and once it is ready, once it is compiled, you can drag it with your code, drag it around, and use it there. So this is basically your DLL, and if you have your DLL in the directory, you can use it. You don't need anything else. And as far as I know, you can also share it with your friends or colleagues, and they can also use this maxw64 file, as far as I know. Maybe there might be some MATLAB version restrictions, maybe some lower level stuff, but most of the time it should work on other computers too. So yeah. Now we can see that we have kind of implemented our sum function, and we did embed into MATLAB. Now, let me basically delete this, by the way. Sometimes you cannot delete the file because it is in use. So if you clear max, and if you delete it, then it's still not working. Maybe we are in the directory. That might be also the cause here. Let's change directory. So let's delete it. Bam, it is gone. Now, therefore, if you use a max file that is most probably already always living in your memory, if you wipe out the memory, then you can get rid of the file for some reason if you need that. So, maybe if you are using C, it might not be that maybe you want to see some more advanced stuff, and maybe C is not enough. So in that case, you can also switch basically to C++. And as far as I know, also to C++11. That's all. That should be possible if I remember correct. Now, let's say next setup and then C++. That should, yeah, that should switch to C++. If you provide C, then it'll just use the C. So you can see that I can choose from different tool chains, but it did automatically choose one of it. So this is Visual Studio C++ 2019. So basically it chose that one here. So there we go. Now switching to C++ might have some advantages in low-level programming, because you can do exciting stuff like std vector, std array. So some advanced stuff is also available. Don't think that this is only limited. This is limited only to C. You can use C++, and using these standard libraries can help you very much out here. For a reason, for example, if you have file operations, if you have some data structures that you need to use that is in C, you can use C++ and the modern C++. So this is not only restricted to C, you can also use C++. So I'm not going to go into detail for C++. You can just work your own way out. So this is the first part, basically. I'm not going to go into much detail for the vector implementation. I will show it to you with my, as you can see in C, we are asked to repeat it for row vectors, but I guess you get the idea from the repr function here. So therefore I'll skip that for now. Now, this is version 1, where you can implement many libraries into functions, and then you have your whole library in Matlab. So you can pick some functions that are necessary in Matlab, compile them with Max, and you're good to go. You can use them. Now, what about Simulink? Now, for the Simulink part, I'll use the actual Matlab interface. So let's open up Matlab. Now in Simulink, we will again use Max here, but not directly. Simulink will use Max here. So let's create the same function csum, for example, here in Simulink. So in order to do that, so where are we? We're here. So let me create a folder. New folder. Let's say part 2. Let's go into it. There we go. Now let's open up Simulink. And let's create a model, like model. Takes quite some time. Yep. Now we have our Simulink model. What we are going to do is we are going to look for the library browser here. There we go. And then let's go to user-defined functions. And then S function builder. Now this is the easiest way. This is not the only way, but this is the easiest way. So there we go. We have opened up a, didn't we? If I close it, I forgot to drag and drop it. Yeah. There we go. Now this is a special block, as the name implies. It will generate an S function. So here we have a block, which has nothing much to do here. If we double click it, this window appears. There we go. And unfortunately, I'm not going to be able to zoom in here for some reason. Yeah. Now, this S function here will use C code here. So we are basically coding C here, which is quite handy. And what we can do is we can do the following. Now you can see that we have U0 and Y0. Now these are defined here. You can see that there's U0 and Y0. One of them is input, one of them is output. Now let's maybe rename this to A, and then this maybe to C. And you can see that it will directly take effect. So before I go much into detail, I can show you the following. Now, here, there are some gray areas. And there are some areas where we have white background. The reason for that is that this is basically a template. And in the template, you're not supposed to change these function names, their input, their output, their data types. You're only allowed to change their internals. And let's see. Now here in the system_start_wrapper function, let me just use printf and print something. Let's say initialize. There we go. Now we save. By the way, we need an S function name here. Let's say summer, something like this. Now we have build here. We did hit build on this. And you can see that there's a summer wrapper.c, there's a summer TLC, and there's summer C created here. And the output here shows us summer.maxw64. So basically, we're again creating a max file using C, or maybe C++. It depends on max-setup. And it will be a Simulink block. So if I close this, I save it. Now it is called summer, and it has some extra functions here. Now you can see that there's a mat file. I don't know what the internals are. There's a RTVMake config file, which is also not really that important for us. But we have a C file here. If I click it, I can see that this is automatically generated, and it has quite a lot of in it. You can see S function levels, which indicates that this is a low-level S function. There are multiple S function implementations. You might use Matlab, you might use C for S functions, but we are using low-level C, so yeah, that stands for that. Now it has some definitions which are important, but not to us for now, at least. It has a simstruct, which is a way of accessing data between C and Matlab. Then we have wrapper functions. It goes on and on. You can see that MDL initialize sizes, which stands for model initialize sizes. So these are not that easy to understand. If you try to code your own S function or Simulink block, these may become important, but it is out of our scope because we want to simplify stuff. The only thing sometimes, or as a programmer most of the time, is that I want to port my C code or algorithm into Simulink, and that's most of the time it. I don't want to go into much detail. So therefore, I skip these parts if I use the S function builder. So Matlab helps me out here. It generates all the necessary low-level stuff that I should do if Matlab wouldn't help me. So the job gets done basically. And the only part that I'm interested in, you can see that there's a sample time, or the sample time of the model. There are output ports, input ports, all the stuff necessary is already in here. But then you stumble upon this static void function, MDL start, and it calls the summer_start wrapper. So this is basically the only function that I see in my S function builder interface. If I double click it, I'll see summer_start_wrapper. So this encapsulates my code and gets rid of all the necessary stuff. It carries out the work for me. So this is called once when you run your model, and then outputs wrapper, which is basically termination as far as I remember. Oh, this one is termination. And then we have outputs wrapper here. So we don't have to know everything in this file if we're just interested in importing C into Simulink. So we can just use this interface here, which is neat. Now I have built it. So this is basically building my library. Now, if I'm in here, I can just save this under test model, maybe SLX, and then run it and see what happens. Now you can see that we have some input-output connection problems. Okay. But other than that, it should basically work. Now here, let's, let's hit run again. And these are the only warnings. Yeah, okay. So since I will have two inputs, let me just quickly create another input. And the way of doing that, I want to have another input port here because I want to provide a constant A, for example, here, and then a constant B. And my low-level C function should calculate A plus B and then maybe put it in here so I can access it via C here. So I need another input port. So I'll right-click here, add an input, and that's it. So give it a name, a suiting name. And since I'm only interested in the 1,1, so scalars, this is enough for me, sufficient for me. So you can see that there are dimensions and complexity, and there's real something like real. We did code this. This was create numeric matrix, MX create numeric matrix, which had arguments, row size, column size, and then the complexity MX real. We also provided a double class. You can see that it's kind of the same. And behind the scenes, it'll just use MX create numeric array function. So it'll allocate this for me. So, but here we are in Simulink. So there's more to it. So yeah, using this interface simplifies the stuff. So yeah. Okay, now we have two inputs. Let me again compile. Let's hit OK. It takes a bit of time. And when I close it, save it. There we go. Now we have two input ports and one output port. So maybe I want to grab a constant block here. Let's have 1 and copy it. Let's have, for example, 3. And then maybe a display because we just sum them up. There we go. So, of course, we do nothing here. So therefore, we have no output. Yeah. But we can see that we can run our block And as far as I can see, there are no problems. So I'm only curious about this initialized part here. Why don't we see it in somewhere? But okay. Now printf for some reason doesn't work now. I was expecting something else. So let me just quickly check it out. Okay. Now, by the way, we did use this interface here, right click and then add input, add output. There's also something called add parameter, which uses an interface, which I'm going to show when I'm done. Now, and then there's also libraries. So here in libraries, you can add path and entries. So you can basically use this CMake or CFlag system to include the libraries, which is also possible in Max. If you look up the documentation for Max, it'll show you that you can pass in compiler flags and arguments. It's also possible via this S function builder. You can see here. So that was compiling. Here somewhere we have compiler flags. So this becomes important if you have already a library that you should compile here. So it is possible to compile them. For example, for stuff like OpenCV, STL, or other libraries, you have to provide these compiler flags. So that's possible. Anything else to show here? I guess not. There are some additional stuff, but we don't really care about that. So this is, yeah, you have also linker flags. So you can basically compile anything you want. So because you have those possibilities, and then you have compiler flags. You might want to check this out if you have an advanced application. So therefore, you can also use this interface here for Simulink to add path, add entry, something like that. And you have this interface here. On the right, we have some settings. You can specify discrete states or internals. But if you are porting something that is basically in low-level C, most of the time, you just stick with the defaults here. So, so we can use a language, C, C++, or from the model, yeah. Now, let's try to use C here to calculate the sum. Now, here in the template, you can see that we have y0 equals u0, which is just taking the input and pass it through the output. So you can have complex values, so .im and .re stands for imaginary and real values. So if you have a complex number, you can do stuff like .im and .re, but we are not really interested in that either. So let's calculate a plus b. Now, if you remember in the Max demonstration in part 1, we had this const mx array pointer. Now here in Simulink, the implementation is a bit different. We have, again, const because we will only read the values of a and b to not mess stuff up. But we have the writing permission for C. And here we have a pointer and a B pointer, and then a C pointer. So these are, again, pointers. So this has the same notation as in in Max. So basically, we're using the same interface. Therefore, what you should do is you should go ahead and use A and dereference it with 0. Now here the difference is that we don't use mx get pr or stuff like that because it is already sort of a double. So you can use real underscore t, which corresponds to double, which will correspond to double as far as I know. So we can do something like this. We have a 0, and then we can, for example, assign C to it. So that was also the predefined line here. You have to put in a semicolon because this is basically C. So let's close this. All right, let's open up our Simulink model and hit run. Now you can see that even though this is not the sum of 1 and 3, I have directly put the value of A into C. So in order to have sum, what I need to do is I need to use A and then plus B 0, and then this will calculate the sum here. Of course, this is again a trivial example. Therefore, having this A plus B here might not be that exciting. But you can see again, there's the potential of having an include here. For example, as far as I know, I can include IOStream, which is a C++ standard library. And then let's, by the way, try this with std_cout. And then let's say start it, new line character, and then semicolon. So maybe we should also change it to C++. There we go. Let's compile this, hopefully. Good. And then let's close it and then run it. Now here, it seems like I have to use std IOStream, the standard IOStream from C++, for this to work. Now, the init function is now called, and I can see that it writes down started. So if you have some initialization of libraries and creation of variables, local variables, then this function is the init function that you should implement. So if you have, for example, a library, the library init should be called in here, basically. So the initialization function is here. And then you have also the termination function, which is basically the same. So terminated and then dot. So which basically handles stuff once your whole library or C++ code is executed. So let's have that. Now you can see that it started and it terminated. So this is quite nice. And what I can also do is I can print out values in here, which is maybe not a good idea, but I'll do it. Let's say C, and then provide C0 to show if it's compatible with the standard C++. So now you can see that there were only 2 steps here. So this was called only 2 times, even though it had a stop time of 10 seconds. This might be because of the auto variable step discrete solver. So let's change it. Let's say we want to have fixed step, and let's have OD4, for example. Interesting. Solvers are updated, I guess. Where's Runga Kota? I don't see it. Yeah, let's have OD45. Again, variable step. I want to have fixed step and OD4. There we go. Now, and the sample time should be 1 second, for example. So when I call this now, maybe, interesting. Now, I guess we need a sampling time in here. Yeah, we have a sample mode and inherited. Okay, let's change it to discrete and say we have 1 second of sampling time. Let's build this. Let's save it. Let's save it. There we go. Now we're talking. Now we have a 1 second sampling time, and you can see that the fixed step size is automatically equal to 1 because my model has sampling time 1 second. Therefore, I have updated it. So we can see that this is discrete and it is equal to 1. By setting the sampling time, I can see that my model, the main function of my model, which is basically summer outputs wrapper, this function will be called 10 times. Or 11 because it starts with 0 because of the sampling time. So at each iteration, each step, this function is called to determine what the outputs of this block is. So in order to have something like maybe a sine wave, let's have a sine wave. Not the sine function, maybe the sine wave. There we go. We will have the sine wave, and let's add in some ramp. Now the nice thing about let's have also a scope about this S function builder is that our algorithm will be called at each step. So therefore, it doesn't matter if you have sine waves, if you have ramp functions, you can just basically implement your sum function. And you can also debug your block for each step and see what the values actually are. And you can also have this plot here. If I double click it, there we go. I have a weird ramp sine sum with 1 second sampling time sort of signal, but you can see that we can have this debug information using the std cout, and we have a sampling time. By setting the sampling time, you might have a different sampling time than the actual model. This should be this is not constrained on that, but as far as I know, this the sampling time of your block should be the sampling time should be, I guess, greater than or equal to the sampling time of your model. Now, since you have C++ available, what you can do is you can do some interesting stuff here. And I'll show you in a second. Now, where is it? So since we have C++ here, and I'm not sure if we have C++11, but we should. So when we include, for example, vector in here, and then maybe create a local std vector vect, something like this. So this should be a vector of, let's say, floats. This should be possible. And I might push the values, dot push back, that are in here. Let's try this out. Once this is done, I might go ahead and look for the length of the stored data here. So std cout, and what was it again? Was it size Let's see. Was it length? Was it size? I guess it is size. Vect.size. Values are stored. And then new line. So hopefully we don't have compilation errors. Let's check it out. We have now maybe std vector example. Maybe an example would help us out. Yeah. So maybe it's size with the parentheses. I don't know. We have only warnings, by the way. Push. Is it push? Maybe not pushback, but push. Failed. Let's try size with parentheses. Still not solving it. So push, not a member, so pushback is it? It is basically pushback then. Let's have that. Yeah, successfully. Okay. Now it took a little bit of time. Sorry for that. So we have compiled it. And when I close it, save it, and run this basically, I can see that 11 values are stored. Now, the interesting thing is the following. If you need a memory, for example, for your algorithm, then using the std vector here, the standard vector implementation, using pushback, you can easily have a memory. So you have your C++ code, and you can utilize those functions that are available for the standard library. For example, the sorting algorithm, for example, this vector structure here. So there's basically no limit to this. You can have complex C++ or C codes that you can implement here. And the S function builder helps you out in creating your algorithm in Simulink. And it works, it directly works if you have a working C++ example, for example. And you can use external functions, by the way, which I didn't show here, but you can have C functions or C++ functions defined in the same directory and directly use them. So you are not restricted to this template. This template is basically the wrapper function that we have implemented ourselves in here, for example. So you can just develop it in C, C++, and then use this template as function builder and include your files here. And you can also have some different paths and entries in here. You can have also a parameter. Let me show you what the parameter does. So let's basically build this, save it. Sometimes we have to get rid of the generated values here, or files. Let's get rid of the TLC wrapper. I guess these here. Let's delete them. I'm not sure about Summer C. So Summer C++ test model. So let's close this. Let's come here. Let's save this. Let's open it up. Now you can see that we have a parameter in the screen, on the screen here, and we can modify the value of the parameter, and it will be used in the code that will be executed here. So we have access to this P0 here, and the P width, of course. So you can basically provide some static parameters to your block, define them, to use in your Simulink block. Let's build this again. Let's see. There we go. Now, if I close this, if I save this, if I run this, so basically it has no effect, but maybe I can show you that we can use this P0 value here. Let me just, now you can see that this is here, so P0. So maybe, oh, let's open it up again. So we have P0 available here, std cout, static parameter, and then P00, basically, new line. And then build this. So let's close this and run this. Look for here, you can see that the static parameter is equal to 1. Now, if I change it, let's say 256, this could be maybe the memory that you will have, or the memory restriction that you will have. Depends on you. So there we go. The static parameter is now 256. You can have as many parameters as you want. And you can see now that I have a nice set of helper functions in the S function builder built in. And there I can also have every step documented like this. I can print out, dump the values of the variables there. I have a termination, and then I have, for example, 22 values stored. Now, I guess it'll increase and increase 33 on execution because we didn't get rid of it now. It increases again. So maybe you can go ahead and empty it. I don't remember if that was the case, but is there something called empty or erase elements? There's something called erase. So maybe we should call erase. But it needs some iterator stuff. I am not sure if it's going to work, but you have to basically be familiar with the standard library. But you can also go ahead and implement your own class, own memory or data structure, and then include them and use them here. The only thing that I did here was to use this part here to define my variables that will be used throughout execution. And that's basically it. So my variables, my local variables live here. So basically I can create whatever I want here in C, C++, and use them throughout these functions because it is defined in the scope. So basically we have, let me just close this, let me close this. By the way, you can also edit some advanced stuff, I guess. The appearance can also be changed as far as I remember. Block properties, there are some properties, and then in block, and no, somewhere else. Let me just quickly. Yeah, this is the block number as function name. That's basically it. Yeah. Okay. Yeah, I guess. Okay, you can use the basic format stuff here to change the appearance here. So for example, if I say format and then have some different values, you can edit this basically. If we explore it, we have some extra capabilities, but this is basically limited to the all the blocks in Simulink. So you can have some additional setup here. But using a S function block, a builder block, is quite easy and straightforward. You have a template that is automatically generated, takes care of the low-level stuff. What you have to do is you have to include your headers. You have to provide some, if you need to provide some path or flags, you can do that here. And then you have a init function, a terminate function, and then a step function, basically. Every time we execute the model one step, this function is called automatically. So you can manipulate using the makes function notation here with dereferencing the first one, the second one, etc. You have also the capability of having static parameters, and using these static parameters, you can have some external input to your low-level C++ code. And it is also possible to include some extra libraries that you have maybe coded, class files, etc.